Good afternoon, everybody. Thank you so much for joining us today for another EI Live for K-12 students and educators, brought to you by the Earth Institute at Columbia. My name is Cassie, and I'm the director for the Office of Education and Outreach, and a big part of my job is bringing our scientific research to different audiences, including students and educators. So for those of you who aren't familiar with the Earth Institute, our core mission is to foster a greater understanding of the science behind sustainability and the climate crisis, and what we as global citizens can do. Experts that make up the Earth Institute include earth scientists, economists, business and policy experts, and specialists in law and public health. The Institute is made up of 2,000 or so research centers and several hundred people who collaborate across many different disciplines within the university. What we're hoping to do with these interdisciplinary sessions is to introduce you to our work through our experts. And we're going to have these sessions until the end of June for K-12 students and educators. And we're also working on EI Live content so that we can add to our series of live stream content and sessions over the summer. So today we're going to hear from Dara Mendeloff of the Center for International Earth Science Information Network at Columbia. She's going to be leading us through a demonstration of GIS and showing us some of the basics to better understand how scientists and experts like herself use GIS and maps to explore social and environmental processes. So please use the chat box just to the right of this window to ask questions. We'll be monitoring the chat box throughout the talk. And once Dara is done with her presentation, we'll go through the questions. You can also feel free to email me if you don't want to use the chat box. Once the session is done, what we'll do is share a link with everyone who registered for the event so that you can access the recording later on. We do make the video private for a few days while we edit it. So once we're all set with that, we'll definitely send you a link to the recording. Feel free to contact me directly if you're having any technical difficulties with the video. And Dara will also be asking some questions today, so we'll also be using the chat box for that purpose. So without further ado, I'll let Dara take it away.
Hello, everybody. Happy Wednesday. Thank you so much, Cassie, for having me here. It's really exciting to be able to do something like this with everybody virtually. So thank you. Just going to hide some screens. I hope you all can see my bright orange pointer today. Or sorry, it's not orange, it's green, bright lime green. I'm going to put it to the side for just a moment. So as Cassie said, I am a GIS professional. I make maps. And so I work for a research center called CEISN, the Center for International Earth Science Information Network. And we focus on trying to understand how humans interact with their environment. So I'll be working with you today on exploring one of our products that we produce called the Environmental Performance Index, and another theme of noise in New York City, because I also work with a small membership group called Gizmo, and we like to work with open data. So open data is something that's going to be available to all of you. And this is one aspect of how you can work with that open data set. Okay, so like I said, CEISN is a research center under the Earth Institute at Columbia University, and we work at the intersection of social, natural, and data sciences. So we have a couple examples that I'll walk you through of the applications of our of GIS and the scientific research that we do. We produce a global population of the world, which just maps out where people are. What types of people are there using the different census demographics that we might be familiar with, age, sex, race. really just where people are. On the left, there is an example of the US Census Grid, focusing on the United States. It's an example of how you can use the census data to evaluate differences in housing age. So you can see the trends of how America was settled from a certain time period. A different application shown here is the human footprint. Some partners of ours at the Nature Conservancy has produced a series of data sets looking at the last of the wild, trying to explore the impact of human development and natural areas. On the top right here, we have the subnational infant mortality rate data set, which is looking at infant mortality rate. And that can be a proxy for an indicator of health, an indicator of poverty. So that's an important data set. Also, we explore things like water quality, which I'll talk to you more about in just a moment. At Season, we host a CDAC data center, a NASA data center called CDAC. Lots of acronyms. CDAC stands for the Socio and Economic Data and Application Center. So we use remotely sensed information with the more some census and human-related data to make sense of what could be going on. On the top left here is the EPI that we'll be working with today. It's the Environmental Performance Index, which is basically a score per country that indicates how well they're performing based on, I think, 24 different variables. So we'll explore a couple of those variables today. On the top right, we have PM 2.5, which is often used as an indicator of air quality. On the bottom right is that human footprint that I was telling you about. And on the bottom left is the subnational infant mortality rates data set that I also just mentioned to you. So this is a map viewer that can be used in education, or if you just want to kind of explore what kind of data sets we produce and distribute. This is a 4-pane viewer that you can explore all of our different data products and compare all of them in this one viewer. Another product that CDAC produces is the Hazards Mapper. In the Hazards Mapper, focus on natural hazards. And the bonus with this is that we allow you to calculate population. So in the background in blue is the population count for 2015. And you can use a legend to identify what all these circles mean. The circle with the dot in the center are earthquakes, and the solid green circle with the lightning bolt are nuclear power plants. And so if you want to understand the relationship between, hey, there's an earthquake occurring, if it's near a nuclear power plant, then what are the populations that might be vulnerable? And how that works is you can draw a buffer. You can use a circle. In this case, I drew a 30-kilometer buffer around a nuclear power plant and calculated how many people are in that area, an estimate of the population. And this is the Indian Point in the New York area. About 1 million people are in that area. So lots of applications for this kind of work in the field for risk management, emergency services, and other types of researchers. Another data set that I'm currently working on is the Food Insecurity Hotspots data set. Food insecurity is prone to a lot of areas in Africa, in Central America, the Caribbean, Central Asia. So with this data set, FuseNet constantly monitors situations. And so we're providing a hotspots data set that looks at 10 years worth of information to evaluate hotspots and different trends that might be occurring. Here is another version of the human footprint. The same folks that created the human footprint are developing or have developed the development threat index. So with this, you can look at what areas have a potential threat to future development. It looks at a variety of variables such as agricultural expansion, urban expansion, mining, and energy. And so there are several different layers of information that you can look at per sector to evaluate potential areas of threat due to those sectors. The same folks have developed the global development potential indices. So not those that are not those areas that are threatened, but rather those areas that have the potential for development for similar sectors. This is an example of areas that have the potential for development for biofuels. Mapping where people are is quite important. And so we produce several different data sets, the global population of the world, and this is an example of the US Census grids. You can see we start thinking about map interpretation. The darker the area, the more densely populated it is. So in this area, the darker brown are more dense areas, and those are all of our urban areas. Speaking of urban areas, here's an example of that data set in New York City. You can look at poverty level. So we have 50% of people living below the poverty line. On the bottom right, we have average household income. So there are a lot of different ways to look at where people are living. Here's the example of water quality in Jamaica Bay that I was telling you about. Water quality is really important for recreational purposes or for fishing. Jamaica Bay is a well-populated area and used for, it's also a great barrier for flooding. So in this database, we look at a lot of different variables that have been collected over the past 100 years, such as water temperature, air temperature, fecal matter, oxygen, chlorophyll, fluorescence. So this is also an interesting GIS project. A very different project that I recently completed was mapping sustainable development goals in a mining community in Chile. So being able to align a lot of those data sets I was talking about to sustainable development goals for the 2020 and 2030 goals is quite important. So this is an interesting application that the same GIS and data analysis can provide. Here's an example related to flooding. So Hurricane Sandy happened several years ago in the Northeast. Well, it happened, we analyzed the Northeast. So we wanted to know who was affected. So using the same global population of the world, we calculated, given the impact, how far the storm surge inundated, we calculated how many people were affected, how much land was affected, and what was the actual distribution of the impact. A different application is in the urban planning world. So zoning laws are very effective using GIS. So you can overlay zoning with the proposed developments. You can better understand where commercial overlays are, where you can develop certain open spaces, certain parks, and where all these rules, land parcels, overlay. This is my favorite map. This is a map of tropical cyclones for about over the last 150 years. NOAA produced this data set and this map. I love it primarily because it is a quite simple looking image, but it's about 150 years worth of information. And just by looking at the color, you can tell where the most intensely trafficked hurricanes occur. No labels, it's just a very striking image, but knowing data and GIS, I know that the back end of this is quite complex. So the visual side is stunning and a very nice way to interpret all of that complex data. So with those examples, I hope you understand that the applications of GIS are infinite. You can apply GIS anywhere. Climate change, it's data for climate and weather is everywhere. So you can assess climate change, precipitation, soil moisture, wind energy, health. So in our current pandemic, GIS is being used all over the place to track this illness. Crime, asset management, agriculture are also places that you can apply GIS. So what is GIS? GIS is a combination of maps, the visual, as well as tables of information. So in this image, you can look at a map of countries, and there's some points representing cities, and directly linked to that is a table of information. So you can see that the city highlighted in bright blue, Bombay, is also highlighted in the map. These things are linked together, and it makes analysis and being able to overlay multiple layers of information really powerful. And it allows us to do the second bullet here, describe processes, identify patterns, identify where things are and when those things are there, how those things are related to each other, and we can then identify where are suitable locations for new things. Because time is a huge variable that is often overlooked, and we'll explore that with our noise complaints exercise in just a moment. So GIS requires understanding layers of information. So layers are thematic layers of information. In this example, we have streets, water, parcels, and soils. You can have lots of different types of layers, but the idea is that they're all in one place, so representing the same space or location, and they stack on top of each other. You can turn them on and off, and that allows us to create a map. Each one of those layers is composed of features and attributes. So in this example, we have the map of states. In the United States, we have about 50 states. Each is a polygon here, and they're directly linked to this table of attributes. So we have the state name, we have an abbreviation for that state name, we have the population in 1990, then we have the population in 2000. You then have the area of the state, and you also have things like household income. All of that information is linked to these polygons, these states. Because those things are related, we can then make a map of each one of those things. So this arrow is pointing to a map of population for 2000. We can very well make a second map of population in 1990 and then compare visually the distribution of those two things. So that's what we're going to work on today using the Environmental Performance Index. This is what your map could look like. It is showing you visually the distribution of the Environmental Performance Index. So the darker the color here, the higher the rank or the higher the EPI score. And the lighter purple is showing us the lower the score. In order to get there, first I want you to understand what the EPI represents. And so EPI represents a score for every country. First, we look at two broad categories. One is looking at the protection of human health from environmental harm, and the other is looking at the protection of ecosystems. And those are the two broad categories, but underneath there, we're looking at 24 different indicators. Those indicators are air quality, water and sanitation, heavy metals, biodiversity and habitat, forests, fisheries, climate and energy, air pollution, water resources, and agriculture. So if you keep that in mind, then when we look at the map of what the EPI score for every country, then we have a better understanding of what we're actually working with. And to do that, we're going to start with a map that looks like this, which is just an aerial photo, really, or a remotely sensed image of the world. But on the left here, we have layers of information. Those are the thematic layers that I was just telling you about. So we have the EPI 2018 layer, world countries, and then this is the original data that you download from the website. I'll tell you about that as well. So I think Cassie has already shared with you those links, so we'll pull those up in just a moment. Don't go there yet. Through this exercise, we're going to learn the basic GIS functions about how we obtain information about the data, as well as identify patterns in the EPI. And then the second exercise we're going to work on is looking at noise pollution or noise complaints in New York City for the first week of May. So in this map, our final output is going to be displaying the majority of noise in New York City. What are the majority types of noise that we're talking about? In this example, it's loud music. In some neighborhoods, it's car and truck horn. And then in one neighborhood, it is construction before or after hours. So I'm going to show you how we got this. And then, of course, not just the type, but also how many people are complaining about that noise. And in order to obtain that map or create that map, we're using an open data set from New York City's 311 service. Now, there are 311 services in other cities. Somebody the other day had asked if can you compare to other cities? And yes, you probably can, although you're going to have to obtain that data a little bit differently. So 311 is a service that allows us to access information about our government services, or there's a complaint line. So often people call and complain about something going on in their neighborhood. So a popular thing that people complain about is noise. So we're going to explore how is noise occurring. We're going to use that as a proxy for a noise going on. And I was thinking to myself, okay, we have this social distancing thing going on. That should mean that the city is a little bit more quiet, right? Well, maybe, maybe not. So we're going to explore that, and we're going to answer questions like, where would you expect the noisiest place in the city to be? If you're curious, this is where the data came from. It's the 311 service request from 2000 to the present. There are a couple different ways to obtain the data, and I shared the links here with you. And in order to do that analysis, we're going to start with this map, the exercise, with the exercise URL. We're going to start with something that looks like this, and end up with something like this. So I'm going to take a pause here. Maybe we can take a question or two while I switch screen.
Sure. So we had a question. Before I skip to the question, I just want to remind our viewers that if you scroll up in the chat box, I've copied and pasted all of the links. So what you want to do, Dara, do you want them to open the noise exercise link?
Sure. Well, let's start with the EPI one.
Okay.
So,
All right. So we'll start with the
EPI
exercise. If you have any issues with the links, let me know. If you can't find them, let me know. So there was a question about whether or not ArcGIS map software, is it the same that this particular person referred to Johns Hopkins is using for COVID-19? It looks similar. Also, can these maps be used to forecast and create projection models, or does it just reflect real data?
So good question about the product that we're using. So a GIS can be any kind of software. There are several different softwares out there. We are today using an Esri product called ArcGIS Online. It's not a desktop version. There are desktop versions. There's, back in the day, there was ArcMap. Now there's ArcPro. So they have different purposes. ArcGIS Online is more friendly, and you can create applications easily with it. But I think the question was, can you do modeling with it? If you're going to be doing modeling, you might want to use a desktop software because it'll be more suitable for heavy processing like that.
Okay, great. And another question has come up. What does food insecurity mean? I think maybe this was one of the things on the map that was shown. Yeah.
Good question. I would bring up the map, but that'd be too complicated. So food insecurity means that there's a lack of food access in some respects. So in this case, we have, I think, 5 different categories of food insecurity: minimal, crisis, famine, or extreme. So this is really, we have a little bit of food insecurity in urban areas these days. So it's very similar. If access to food is a problem, we're talking about insecure areas.
Okay. Great. Thank you.
Cool. Okay, so I'm going to turn off my video so I can save some bandwidth while I share this with you. And we're going to start with the EPI exercise. Okay, so when you first load the EPI exercise, like I said before, this is just an image of the entire world. On the left-hand side, if you follow this bright green arrow, you have a legend, a content tab, an about tab. You also have a details button and a base map option. Let's just start with the base map option. You click on base map. There are a variety of different base maps that you can choose. Even more than I thought were available. Some of them are really cool. For this exercise, I'm going to choose the light gray, which is just the light gray canvas. You can have fun and choose whichever one you think is appropriate. I'm choosing the light gray primarily because I want us to be able to focus on the colors that we'll be exploring with the EPI. If you then click on the Content tab, you'll then see several layers. You can check these layers on and off. When you check the layers on and off, you'll see, well, for the EPI alone, you'll see that there's no EPI score for the bottom half of the world. So I can zoom in and out manually using this plus or minus button. We're all probably familiar with that. Or you can hover over the three dot menu to the right underneath your layer and click on Zoom to. And that'll take you to the full extent of this data layer. So that was just clicking on the more options, those three buttons, and clicking on Zoom to. You can easily interact with, so this is a web map. So you can click on any of the features on the map and obtain a pop-up. On the pop-up, you'll see a bunch of attributes. Tells you the continent, tells you the country, tells you the country code. And then if you scroll down, gives you the EPI current and a bunch of other variables. The EPI current is the EPI score. So for the United States, the EPI score is 71.19. If you click on a different country, maybe Russia, you can see that the EPI score here is 63.79, which is a little bit lower than the US. And maybe if we click on China, what is China's score? China's EPI score is 50.74, again, a little bit lower. Now that's how we obtain information, by clicking on features on our map, but that's not much of a map, right? Because all of the colors on the map are the same. So how would I know that the US had a little bit of a higher score than those other ones? Before we change the colors on our map, I want to show you the attribute table. So if you hover underneath the EPI layer and click on that Show Table, when you click on Show Table, it opens up the attribute table that's directly linked with our map. And here you see a bunch of columns. Each column tells us a different set of information. Here we have the ISO. If you're familiar with ISOs, it's just a shorthand name for a country. You have the name of the country. If you scroll to the right a little bit more, you've got the continent, different spelling of the country name. And then you have the EPI current. And then you have all these other, those 24 variables that I was telling you about, if you scroll all the way to the right. So without changing the map, I want to show you how you can obtain basic statistics for each one of these variables. So if you click on the EPI current on the top of the column name, you can sort ascending or descending, and you can also click on statistics. If you sort ascending, it sorts the entire table and gives you, I went a little bit too far. The first record in our table here is the country with the lowest score. And in this case, it is Burundi. You can click on the actual row in your table. And on the map, if you zoom around the map a little bit, it'll tell you where Burundi is. I couldn't have told you that without having this interaction. So Burundi is actually over here. What about the country with the highest score? We can sort descending. And it looks like, here's the EPI score, it's Switzerland. So where is Switzerland? It's the blue highlighted country over here in Europe. So we haven't done that much yet, but we've identified both the highest score and the lowest score for EPI. What about the average? If you go back to the column header for EPI and click on statistics, gives you some basic statistics. Tells us out of 181 countries, the minimum value is 27, the maximum is 87, the average is 56.48. So now we know how to gauge these rankings a little bit better. So I want to ask you guys now, if I tell you that this column here, air.current, represents air quality, can somebody tell me which country has the highest air quality score? And then, because this takes a little bit of time, also, what is the country with the lowest air quality score?
Thanks, Dara. I'm just going to retype that question into the chat box so that people can see it and remember what it is. So you're asking what is the country with the highest air quality score and what's the country with the lowest air quality score. Is that correct?
Correct.
Okay. Okay, great. And while we are doing that, we've had another question come up, so we can address that while people are working through your question. So do you keep editing the maps when new data is found? And the second part of that question is, what's a hard part about making the maps?
Let me see if I can put my video on to answer this.
Yeah.
Those are really good questions. So in some cases, if there's funding available, yes, we'll update the maps. So the EPI that we're working with right now, my colleagues reproduce this or update it every 2 years. So there's new data available quite often. And so they'll reprocess this, using different input as well as different methodology to make improvements and distribute this every 2 years. So there are some data that are updated quite often, others not so much. In terms of modeling, yeah, for modeling, also related to funding, but so if you think about how the Earth changes, satellite imagery is constantly producing new data, but we don't always have the opportunity to integrate that with our data products. So it depends on a couple of variables. And then what is the hardest part about working with these maps or creating these maps?
Yeah, or one of the hardest things.
One of the hardest things is evaluating which data should be used and incorporated into this map. So we spend a lot of time evaluating the quality and the validating good data and making sure that it's clean. So all of this information needs to be processed and cleaned and vetted. So QA/QC is a very challenging but very important part of this. So making a pretty map, it could take a lot of time to make a very pretty map, but making sure that the underlying information to that map means something takes a lot of time.
Okay, great, thank you. So while we were answering that question, we've had a lot of responses come in. So it seems like there is a consensus that the country with the lowest air quality rating is Nepal. And then the two places with the highest ratings are Barbados and Australia.
Cool. Okay, so I'm going to try and figure this out and see if you guys are correct or if we get the same answer. I'm going to do that by clicking on the column for air and sorting ascending. And my answer for the lowest air quality score is also Nepal with 3.94. And then if we do the same thing for descending, oh, you guys are correct. So Barbados and Australia both have an air quality score of 100, so they are tied for first place. Awesome. So you get the idea. You can interact with this GIS data without producing a map or a pretty map. So now that we know a little bit more about the underlying data, let's go ahead and change the colors of the map. So we can close out this table. And if we go back to our EPI layer and click on Change Style, which is the geometry option. In step number 1, you're going to change Show Location Only. You're going to change that to your EPI score. Or because you're familiar with the air, you can change it to the air or the EPI, whichever you prefer. Play around and have some fun. Now that those ranges of values have been cut up into different colors. If you don't like the default color, you can go ahead and click on the options for counts and amounts. And when you get here, you can see how this is a histogram that shows us the distribution of the lowest score to the highest score. This is a way of classifying that range of values. If you click on symbols, though, sorry if you missed that, it's the symbols option on the right side. You have an option for looking at different colors. So go ahead and pick your favorite color. I'm going to choose a shade of purple. Okay. If you remember, the United States had a pretty high score, but for some reason it's given a lighter color. I don't think that's appropriate, so we have an option to invert the color ramp. So I'm going to click on invert so that it switches the high and low colors. So now the darker the color, the higher the EPI score. And I'm going to click on OK. And now we have a map that's telling a story. And for the sake of time, I'm going to stop there so we can move on to the next map. But if there are any questions about this, feel free to put your question in the chat while we change to the second exercise.
So there is one quick question about Nepal and what's contributing to the low air quality score for them. And do you think whether topography has anything to do with it?
That's a good question. I cannot give you an answer for that. I don't know. I would say if you could look into it a little bit more and then get back to us, I'd be happy to look into it as well. It could be elevation, but what about the elevation would be creating that problem or that low score? I don't know. Could be related to the policies in Nepal. I don't know. Good question. Okay, so I'm going to stop video one more time. So now we're going to switch to that noise exercise. And you're going to switch to the Content tab. And you should see that there are many more layers now. So I did a little bit of pre-processing for you so we can explore the 311 data a little bit easier. So first of all, the base map here is very busy. So I'm going to change the base map to something a little bit less busy by clicking on base map and choosing a dark gray for this exercise. The second thing that's a little bit busy are these borough boundaries. I do want to know what borough boundaries, where they are, but I don't need them to be represented in a color. So underneath the borough boundary layer, I'm going to click on Change Style. And I'm going to keep the Show Location Only, but I'm going to click on the options so I can change the symbols And here I'm going to change the fill to no color, and I'm going to keep the outline just like it is. Now we have the outline of the burrows, but it's not a bright, annoying color. Okay, so now that we have a base map that we can work with, I'm going to check on the first layer in our table of contents here, the 311 calls between May 1st to the 8th, and represent them as individual points. So these are all of the complaints that were made in this week, and they're all linked to a particular location. So we can't really tell too much from this other than that there were a lot of calls made. Because this is a time, so there's a time associated, if you click on one of the points, you'll see there's time associated with it. So the creation date, the point I clicked on was made on May 1st at 7:50, and then it was closed on May 2nd at 8:30 in the morning by the Department of Environmental Protection. There's all this information associated with it. But it's a lot, it's overwhelming. Because there's a time slider at the bottom of your map, and you can go ahead and click on play. And it'll take you through. It's actually going to take quite a long time to load. So instead of looking at the individual point, you're going to uncheck the individual point and go ahead and click on the second layer that I clustered. So it's not going to show up on my map because my internet's a little bit slow today, but underneath your cluster points layer, you should see a blue circle that says cluster point. And what that does is it clusters points. Statistically speaking, it takes a bunch of points and makes one big point out of it. So this is a little bit easier to interpret. So if you click on the time slider at the bottom of your map now, I had set this to show 1 day per time period here. So we're looking at 1 day at a time. You click on play, I'd like you guys to just kind of take a look at how things are changing throughout all of New York City. Maybe you can see one borough having more complaints than another. So having a time slider is a really useful function in this application. So we're going to go right on to the third layer. For this layer, I calculated how many calls there are per neighborhood, because for this, yes, clustering the points was kind of useful to see a little bit more clear of a distribution, but we can fine-tune that by neighborhood. So using the neighborhood boundaries, we calculated how many calls were made per neighborhood. You can look at the show, if you show table, you can see that there are counts of points, which are the total number of calls per neighborhood. And the UHF name in this case is the neighborhood. And then you have borough. So you can get a total number of points per neighborhood. So let's go ahead and change the style of our map to reflect those numbers. If you change, so underneath that same layer, you're going to click on Change Style. Wrong icon. There we go, Change Style. And we're going to click on Count of Points. All right, so in the second option, we're looking at counts and amounts, but every neighborhood has a different size point showing us how many calls were made in that area. which is kind of cool. So now, actually, let's go ahead and ask folks which neighborhood. You can either look on the map, or you can open up your attribute table, show table. Can you guys tell me which neighborhood had the most calls?
And while we wait for our participants to answer the question about what neighborhood had the most 311 noise complaint calls, Dara, what are some of the coolest or most fun maps you've ever got to work on? I know you mentioned that the NOAA one was one of your favorites that you really liked, knowing, you know, it's a simple map, but knowing the complexities of, you know, 150 years of data. So what has been some of your favorite, what has been some of your favorite map projects?
Good question. I like all maps. So I like just making maps and working with new types of data. So I, by default, have to say the most recent projects I've worked on, the mining in Chile was really exciting because I didn't even get to travel to that location, but was making maps of the area. And working with different types of information. So for me, the challenge of that was quite exciting. Working on this noise exercise was really interesting. So I like working with data that's freely available to us and trying to make sense of it. So this was quite exciting to figure out, okay, if people are complaining about noise, how can I better understand that? And being able to visualize it using this application is really exciting for me. So.
Great, thank you. And it looks like, so we have an answer about what neighborhood had the most calls. It looks like the northeast part of the Bronx. So Dara, would you agree?
That's the same answer, northeast of the Bronx. And so if you highlight that record in your table and zoom over to the Bronx over here, you'll see that that is the biggest circle. So yeah, I get the same answer. Okay, so that actually, we were only looking at all of the calls. So now we need to quickly move into the rest of these layers so we can explore the actual noise complaints. So these are all of the calls. And so what I did next was filter this table. I'll quickly show you how to filter information, because remember at the beginning we looked at, you know, thousands and thousands of calls. So how do you make sense of that? Filtering is one of the most basic functions that we work with. And so the filter function here gives you access to all of the attributes in that table. In this case, well, this is not the table that I created, but you can, let's say we wanted to look at neighborhood. It's just a basic expression saying the field name is equal to, or whatever the condition is, and you would type in the value here. So I've filtered for all noise complaints. Oh, actually, here it is. There are several different noise complaint types. There's noise, let's turn this filter on. Here we go. Complaint types equal to noise, noise in commercial areas, noise by helicopters, house of worship, park, residential, street and sidewalk, vehicle. So there's lots of different types of noise that is occurring. Not only the type, but also you can get more specific to that. There are descriptors of how you want to describe that type. So if you go to the change style for the noise complaints by type, you can change to complaints type. And then your map will show a different color for all of the different types that we filtered for. But even more exciting is if you change the attribute to descriptor. Under descriptor, it's a finer, more fine-tuned type of noise. So here we get loud music, banging, pounding, loud talking, car, truck music, idling engine, loud television. These are all the things that people have complained about the first week of May. So that again shows us all of the individual points. And just like we explored all of the calls before, by neighborhood, did the same thing for the noise complaints. So I summarized the noise complaints by type and descriptor per neighborhood. So for the summarized noise complaints type, for this layer, you're going to change the style here. And you're going to change to count of points. And so count of points tells us per neighborhood how many noise complaints there were in total. But then there's an option to add another attribute. So you can change the style to map 2 attributes. Your second attribute is going to be the descriptor. In this case, it's going to be the majority descriptor. So under the first step, choose an attribute to show. I have count of points and then the majority descriptor. And that gives us a color that shows us the different types of the most reported noise, and then a circle showing us how many complaints there were for that descriptor. So given what we've learned so far, we have a map showing, that same neighborhood with the most calls also is, their calls are about noise, and those calls are about loud party noise. But looks like there are 2 other colors here. So my last question to you is, let's turn on the legend. What neighborhood has the most complaints about car, truck, horn, and which neighborhood has the most complaints about noise, construction before or after hours?
Great. And while we wait for our participants to answer those questions, there was a question about does the data for the amount of noise in neighborhoods for this map solely depend on how many calls were placed in complaint?
Yes. So in much of our research in life, we have to use proxies. So it's quite unrealistic that we'll have noise monitors everywhere throughout the city or everywhere in the world. So often we do the best with what we have, which in this case is a wealth of information about what people are complaining about. So we use that as a proxy for noise, rather than a noise decibel, which there are monitors for that around the city and in many parts of the world. But that would be a different type of map and a different type of data to work with.
Great, thank you. And so we have some answers coming in here. So Fresh Meadows seems to have the most car and truck horns.
Cool. And
then someone followed up about someone followed up about proxies and what is a proxy, and so how would you define that?
Okay, that's a good question too. A proxy is an estimate for the real thing. So given that we don't have more proof about the noise going on in a particular area, we'll have something that gives us the next best thing. And in this case, we don't know for sure what's causing the noise, but somebody had called in and complained about the noise. We don't actually know where it is. We only know where the person's call was coming from. So that's a second proxy for location. So proxy can be the next best thing about the data used, or it can be the next best thing about where it's actually occurring. Hope that helps.
Great, thank you. Okay. Yeah, so if you have any thoughts about what neighborhoods you think also have the most complaints about car and truck horns, and which neighborhoods have the most complaints about construction, please type that into the chat box. And in the meantime, we have another question here. So this question is about students who will do independent research projects. What are some good places to obtain data sets, particularly at the local level?
Cool, great question. First of all, feel free to reach out to me. If you have any specific questions, I'd be happy to help you find some good data in your area. But your open data, so if you're in New York City, the open data portal is a very valuable resource. It's a composition of all of the government agencies' data in one place. Not all of it, but it's getting better. And so all of your cities and states have similar data portals. Also, all of the data sets that I first showed you that Susan and CDAC produce is freely available to you to work with. So if you're looking at, you can start it with a global data set and filter it down and maybe obtain some useful information for your local level as well. So I hope that helps.
Great, thank you. All right, if anybody else has any more questions, please type it into the chat box. Dara, do you want to swap to the slide with your contact information so we can, we'll wrap up with that. And if you do have additional questions about anything today, these links will be good so you can go back and play around. And when we play around with the maps and the layers and change some of the variables and answer some different questions, once we have the recording set up and all edited, we will send a link out so that you can kind of go back in the recording and review some of the items that Dara has gone over. Anything else you want to wrap up with, Dara? So you've put up your contact information. Any parting words to our participants?
I just would like to say thank you for your time. I hope I inspired a little bit of interest in map making and data work. If you have any questions, feel free to reach out. There's a lot of information out there. There's not a one-stop shop, but there are a lot of places that you can start, and you might find a domino effect of things to find. You might find that things end up being a little bit challenging at times, but stick with it. Because you can make really fantastic maps and communicate some really good information to the world. So I hope you get to work and share your work with us. Thank you, Cassie, for allowing me to be a part of this. It was fantastic. Thank you.
Great, thank you. Yeah, definitely. If you are creating maps or any other sort of data product, feel free to share that with us. We'd love to take a look and see what you're all working on. So with that, we are going to wrap up the session. Thank you again so much for joining us today. We have we're continuing to have these sessions until the end of June. Next week, we've got 2 sessions on Python and what you can do with Python and an introduction with Josh Russell at Lamont Doherty Earth Observatory. So please tune in for that. If you have any questions about the series in general, or if you have any feedback for us, or if there's sessions that you want to see, feel free to email me directly, and we can definitely, we're planning out our summer, so we can definitely take additional ideas and feedback, and it's always great to hear from people on the other side who are actually watching some of these sessions. So we'll be in touch with the recording, and hopefully everybody else is able to join us for a future session, and we hope you enjoy the rest of your day. So thank you, and thank you, Dara. That was great, and thanks for participating. And we'll see everybody else soon, hopefully.